Alright, that was a fundamental theorem of calculus part 2. So we're going to begin with the second fundamental theorem of calculus, okay? It's very similar to the first fundamental theorem of calculus. So if f is continuous on an open interval I containing a, then for every x in an interval, derivative with respect to x, that's this right here, derivative with respect to x, of the integral of 0 to x of f of t dt is equal to f of x. Why? Because since this is x, and we're finding derivative with respect to that, they basically cancel, and we replace with x because we are finding the integral from x to, or 0 to x, and we're finding the derivative with respect to x. So it's equal to fx. So we're doing some examples where a lot of our examples are going to be based off of the fact that we have an unknown up here. Okay? So we got our first example here from 0 to x, the function 4t minus 7 of dt. So, integrate it. It would originally be 2t squared minus 7t. We did plus c, it wouldn't matter, but, and we are evaluating from x is 0, so when you put x in, you're going to get 2t, not t, because it's x now, x squared minus 7x. Put 0 in, it's just going to become 0, so there's our new function, right? There's our f of x. You might be asked in your homework where it will say something along the lines of find the function of f of x, then evaluate it at x equal to 2, x equal to 5, x equal to 8. So if we're doing that, just simply plug it in, okay? If we plug in 2, what happens? 2 squared is 4, 4 times 2 is 8, 8 minus 14 is negative 6. So therefore, f of 2 is equal to negative 6. F of 5 squared is 25, times 2 is 50. 50 minus 7 times 5 is 35 is 15, so it'll be 15. F of 8 will be 128 minus 56, which is 72. There we go. All right, with this example, we just need to find f prime of x. Okay, that's our goal. We have f of x is equal to this, so we need to find f prime of this. So this is a little tricky here, okay? So just like before, we're going to find, this really applies to the rule. So when we're trying to find the derivative of both sides, we're going from 0 to 3x, okay? Since that's the case, and we're finding the derivative of both sides, the derivative and the antiderivative will be gone, and we're going to replace the t with 3x. Now, this is not the final answer. I'm going to show you something else here. So we cube that inside. It'll be 1 plus, make sure you cube the 3 and the x, it'll be 27x cubed. Now, due to chain rule, anytime we have something that's up here, we need to make sure we put the derivative, whatever this top number is, up front. Okay, so the derivative of 3x is 3. Okay, so your final answer is 3 times square root of 1 plus 27x cubed. So the net change theorem is pretty much our just finding the antiderivative of a definite integral. So you find the antiderivative of this function, just like it would be if it was just f of x, and then you put in the upper minus the lower. So very similar to the other problems, okay? And it gives you the net change as far as like how much you've increased or decreased. So this is problem number 55 on page 442, and it's a word problem, so that's why I didn't write it all out. The volume of V in liters of air in lungs during a 5-second respiratory cycle is approximated by the model v equals 0.1729 t plus 0.1522 t squared minus 0.0374 t cubed. Okay, where t is time in seconds. So we want to approximate the average volume of air in the lungs during one cycle. So as I said, it's a 5-second cycle. So we will be going from 0 to 5 of this function, 0.1729 t plus 0.155, not 522 t squared minus 0.0374 t cubed. Yeah. So we're going to evaluate from 0 to 5. So we're going to get 0.1729 divided by 2 t squared plus 0.1522 t cubed divided by 3, and then minus 0.0374 t to the fourth divided by 4. We use my calculator table function for this, and when we put 5 in, what do we get? And we get approximately 2.6592. But what directions said, make sure we read the directions. So this is how much transpired in 5 seconds. But they want to know the average over the 5 seconds. So we divide by 5 at the end. If it doesn't say average, then we won't be dividing by 5. But it does, so we have to say it's 0.5318. So I divide by 5 because that's how far you traveled, 5 seconds. 0.5318, approximately, seconds. Last one together. This is on page 444, number 89. So we're dealing with a lot of position, velocity, and acceleration. Because remember when we did derivatives, you have your position function. Derivative of position function is velocity. Derivative of velocity is acceleration. Okay? So we need to do some practice with that. So in 89, it says a particle moves along the x-axis with a velocity of the following. Okay. It tells us also at time t equal to 1, the position is x equal to 4. Find the total distance traveled by the particle on the interval from 1 to 4. Okay, so what does this mean? Remember, so if I'm giving you the velocity function, the position function is the antiderivative of this, okay? So I need to find the derivative of this so I can get my x of t. Usually x of t or s of t is what they refer to as your position function, okay? So we'll use x of t is equal to the antiderivative of this, which if I remember, square root is 1/2 power. So I have to, it's originally t to the negative 1/2, so I have to add 1 and divide it by its new power, which is 1/2. So your position function is going to be t to the 1/2, because you add it, negative 1/2 plus 1 is 1/2. When you divide by 1/2, you flip it and multiply it, so it's going to be 2t to the 1/2. Okay? Now, that's plus c. Right? I don't know what my plus c is. That's why I gave you this bit of information. When t is equal to 1, your output's 4. So I put 1 in. If I put 1 in, I should get an output of 4. So 1 to the 1/2 is 1, times 2 is 2, giving us a c value of 2. If we subtract 2, you get 2. So your position function is this. Okay, here's your position. Now we need to evaluate it from 1 to 4 to find out how far did we travel, right? So when we put 4 in, your output is 6 rather. Yeah, 6. And then when we put 1 in, your output is 4. So how far did you travel? You traveled a distance of 2. 2 what? What, did it give you units? No. It's just 2's your distance traveled. Appreciate you watching, and we'll see you in class. Bye-bye now.